Hey everyone, today is our first actual day of AP Statistics, so we're gonna start off pretty easy, just taking a look at some AP charts and graphs. So if you can come with me, we'll go ahead and take a look at how that is gonna go. So you should have received a packet with a handout that looks like this, Lesson 1.1, what was your favorite toy as a child? And if you're watching this with me right now, well, that means that you're not in class and you probably don't have class data to work with. If you are in class and you're kind of watching this, then you do want to use the data that we're going to come up with in class because, well, that's going to be, more relevant to you since that's what you and your classmates are coming up with. For the sake of this video, we're going to use this data here. We're going to pretend we had a class. And actually, no, I think this came from class a few years ago. And 8 students played with Barbies, 9 with Legos, 2 with Ninja Turtles, 8 with video games, and 2 with dress-up clothes. Presuming that means that they had clothes as toys, which I personally find weird. So next thing we're going to do is we're going to say, hey, well, what are the individuals and the variable of this survey? Note that it says variable and not variables. That might give you kind of a hint about what's going to be happening here. When I take a look at this, I think that the individuals are, well, who are the people or things that I am counting? So I am counting students. How many students preferred Barbies? How many students preferred Legos? And the variable here, and it's very tempting to say that there were 5 variables, but there's actually just one variable. All of these are categories for preferred toy or favorite toy. So to kind of solidify that, we're saying we have one variable, and that variable is the preferred toy or the favorite toy. And that one variable has 5 different categories. We got Barbie, Lego, Ninja Turtles, video game, dress-up, clothes. And since I said it already, we probably have an idea that this variable per favorite toy is categorical. Now the rule of thumb here, the difference between categorical and quantitative is when you're doing a categorical variable, what you're actually counting is can be done with a tally mark. How many students preferred Barbie? How many played with dress-up clothes? So we're tallying all the students in each category. Whereas with a quantitative variable, what we're going to do is we're going to take each individual and we're going to obtain a number that somehow describes that individual. So for example, an easy one would be height. We're going to go to each student in class. We're going to ask them how tall they are, and they're going to respond with a number. Since they're responding with a number, and we're not just counting how many students, responding with a number is indicative of a quantitative variable. Tallying how many students fit in the category is indicative of a categorical variable. Okay, very next thing we're going to do is says to go to staplet.com and enter the class data. We're going to make a bar graph and a pie chart and sketch it below. I know this is the first day in class for most of you, so Staplet is a tool that we're going to be using with relative frequency, quite a bit, and we're going to use this to help us, make our charts and graphs when it's appropriate. Now you'll notice staplet.com brings us to this menu here. It looks pretty dry. Not a lot of graphics or anything. It's just a list of different applets. Staplet is a shortening of stats and applets. So these are stats applets. The one that we're going to be using is, well, maybe you can figure that out. Is it a categorical variable or is it a quantitative variable? Okay, well, it's data analysis. We're looking for a categorical variable. Do we have a single group or multiple groups, or do we have two categorical variables? Oh, we have one categorical variable. And right now, we're just going to do single group. So let's click that categorical variable single group and see what that gives us. Okay. Now we're just going to enter in a few things here. We have our variable name is favorite toy. We're going to input data as counts in categories. So we're going to need 5 categories. And then for each of those categories, we're going to put in the frequency. Frequency is the word that we use pretty synonymously with count. And once that's all in there, we're going to begin analysis. Let's click that begin analysis, and we've got ourselves a bar chart. Okay. I want us to take a look at this bar chart really quickly before we go much further. Notice that the vertical axis tells us frequency, and the horizontal axis tells us a category or variable. Okay, that variable, favorite toy, is further broken up into the different categories. So category 1, Barbie, Lego. Category 2, video games and dress-up dolls. Next thing I want us to notice is that visually speaking, each of these bars are separated from the other. Now that's going to be kind of important because that's a visual cue that tells us that this bar graph is different than the histograms that we're going to be looking at later in the course. Later meaning probably tomorrow. Now the next thing that I want you to notice, and probably the last thing that we're going to talk about here with this right now, is that if I change the order of these bars, I'm not going to change anything about the graph. It's still readable. It's still totally usable. Things will still make sense if Ninja Turtles and dress-up toys were switched, or if video games and Legos were switched, or if every bar was in a different location. Nothing about this graph is really going to change. And again, that's something that's going to be different than the next kinds of graphs that we're going to be doing tomorrow, the histograms, where if you change the order of the bars, then that's going to drastically affect, or it's going to make the graph literally unintelligible. So let's copy and paste this bar chart over. Now in actual class, you would have to draw this out by hand. Not that difficult. Most of the time when I ask you to make a graph in class, it's not going to be anything terribly difficult with 20 different categories, and it's going to be simple. Yeah, there's no point. It's like if you know how to make a bar chart, you know how to make a bar chart. The next thing we're going to make is a pie chart. So we'll go back to Staplet. We'll change the plot type over here. We'll change that to pie chart. And we get our pie chart here. The main thing to know here is, again, it doesn't matter how we order these pie slices. The graph doesn't change. The graph doesn't lose any information for us. Most of you have looked at pie charts before, so I'll quickly say that the size of each pie slice is proportional to the amount of data that it represents. So for example, 27.6 of my students in this hypothetical class, their favorite toy were Barbies. 31% of this hypothetical class had Lego as a favorite toy. Now over here on the right is another important part of the graph. It's that it is the key Now, most likely, if you're doing this in pencil, and if you're on the AP test, you will be doing this in pencil. You won't be able to use colors like this. So most of the time people pattern this with, either they'll shade this in, or they'll put stripes, or they'll use vertical stripes and horizontal stripes and diagonal stripes. There are a number of different ways that you can color this, so you don't have to use literal colors. So again, we'll copy and paste this one over. Now, making a pie chart in class is actually a little bit more difficult than making a bar graph. So I would recommend to you that if you are given a choice of a bar graph and a pie chart, you make yourself a bar graph. Pie charts are nice when the pie slices or the proportions are 25% and 50%. But when we get to 27% and 32% and 39%, you're going to have a little bit of a difficulty creating a correctly proportioned pie chart. So keep that in mind. Because of limitations here, pie chart is great if you have a computer in front of you. Not so great if you have to do it by hand. So here we go. With that, we've got our two different graphs here for categorical data. And really, these are the only two kinds of charts and graphs that we'll be using for single variable categorical data. A couple of other tips to talk about here is that we must start at 0 on our vertical axis for the bar graph, and also the bar graphs are separate. Most of the time when we do our bar graphs, we're going to be doing this in counts or frequencies, but it is also possible to do a bar chart using relative frequency, and relative frequency means percentage. When and if you make your pie chart, remember to include all categories, and that central angle should be a percentage of 360 degrees. A little more difficult. Okay, well, next thing. Sometimes it's helpful to graph more than one variable. So this time we'll be looking at a couple of different variables. And for two variables, we're going to create this chart that we see over here on the left. We have gender up at top, and I know more than two genders, but we're just going to stick with this one. Apologies to you, this is an old handout. And on the left here we have type of toy. These are the same types of toys. So if we tease out from here gender from type of toy, what kind of data would we get? Now I have that data. Again, if you have the data from your class, maybe you're in period 2, use the actual data from period 2. Next, we're going to do the following. We're going to find the percentage of students who chose Ninja Turtles. Well, we had 2 students prefer or choosing Ninja Turtles out of the 29 students in this class, and that gets us 0069, which is 6.9%. Watch those decimal points. Okay. Now this number right here, the 6.9% or 0.69, we call that a marginal relative frequency. Now the relative frequency part is easy because we know that that's a percentage, but the marginal part comes from the fact that in order to get the 2, we would need to add together, let me just highlight that, we would need to add together this 2 and this 0 right here. And if we add that together, typically we would put that total in the margin on the far right of this graph. So because of that, we call this a marginal relative frequency. Now we can practice doing another marginal total. For example, if we wanted to know what percentage of students chose Ninja Turtles, we would just add the Ninja Turtle. No, we just did Ninja Turtle. Let's do Legos. If we wanted to do Legos, we would add together 5 plus 4, and that would give us 9. 9 would be our marginal total. And then our marginal relative frequency would be 9 out of 29. Let's compute that real quick. 9 out of 29. That would be equal to 31%. So that's the marginal relative frequency for Legos. Now the next thing we're going to do is percentage of students who are male and choose Ninja Turtles. Okay, so how many students are male and chose Ninja Turtles? That was 2. Now I know it's the same number as the previous exercise we just did, but that number really does come from a different place because it was the intersection of the male column and the Ninja Turtle column, which is just this single 2 right here. So when we're looking at the combination of 2 different categories, we would call that a joint relative frequency. So both categories working together to get that single percentage is a joint relative frequency. And the last one we're going to do for this part is the percentage of females who chose Legos. Now notice how this one is different. Not the percentage of all students, the percentage of females that prefer Legos. Well, how many females preferred Legos or played with Legos? That was 4. That's just this number right here. There's that 4 right there. Well, how many total females are there? Well, if we add that together, that's 7 and 4, that's 11. 11 and 3 is 14, 15, 16. There are 16 total females, and that gives us 0.25 or 25%. This one has a name also. We're calling this a conditional relative frequency, or a conditional relative frequency, because we're looking at what percentage of students preferred Legos or played with Legos on the condition that the student identified as female. So when you make that additional condition, when you're only looking at either one row or one column in your two-way table, then you're looking at a conditional relative frequency. And I don't think I mentioned it earlier, but we might as well mention it now. This type of table is called a two-way table. And it's 2 ways because we're looking at the data from the type of toy that's favored and from the gender. So we have 2 different variables. It's a two-way table. Okay, let's move on. How many variables does that table have? There are definitely 2 categorical variables. Which variable would best explain or predict the other? Well, that's a little bit of an opinion, maybe. If we knew someone's favorite toy, would we be able to predict their gender? Or would it be better to predict their favorite toy based on their gender? In this case, I really do think answers will vary. A typical response here would be that gender is going to predict a favorite toy. So when we say that one is going to predict the other, then we would call the predictor the explanatory variable, and we would call the variable being predicted the response variable. So number 8 says to go back to Staplet and enter the data, and this time make a side-by-side bar graph and a segmented bar graph. So we'll go back over here to our Staplet. We'll scroll to the bottom and we'll go back to the menu. Now this time we're going to have 2 categorical variables. Okay. Now it says response variable. Our response variable we're going to be putting over on the vertical side. We said that that's going to be favorite toy. And our explanatory variable, we said that that's going to be gender. Data goes into this chart. That looks pretty standard. And then we'll go to begin analysis. Just like before, we've got ourselves we've got ourselves a bar graph over here, which looks a little different. Now, if you look at the chart type, it'll tell you that this is a segmented bar graph. Notice explanatory variable is the x-axis. Response variable is going to be the different categories in the stack of the segmented bar graph, the different segments. Notice that the segments are in the same order in each graph or in each bar. There is again a key, but this time the vertical axis here is relative frequency. It's really important whenever you're comparing two different variables that we use relative frequency rather than frequency or count. This is so that it's easier to compare the two different variables. Next, we'll change this from a segmented bar graph to a side-by-side bar graph. Side-by-side bar graph, notice again that this time the bars again have the color-coded. We're again in relative frequency on this side. And then each grouping of bars is our explanatory variable. And the different bars are the different categories. Back at our StatsMedic, we've got our two charts here. Notice that these are the only two charts that we're going to be using for comparing categorical variables. And note that both charts are going to use relative frequency. Now, which of these two charts is better? Well, that depends on what you're doing with it. If you just want to make a really quick and easy chart, I think the side-by-side bar graph over here on the left, that's definitely going to be easier to create. However, if you want to compare the data, the relative frequencies of the categories spread among multiple of another categorical variable, then I think it's probably better, for comparison's sake, to use that segmented bar graph on the right. So, getting down to number 9, how do the bars in the side-by-side bar graph relate to the bars in the segmented bar graph? Well, if we took all of the bars in the segmented bar graph over here and we kind of stack them all on top of each other, you would create basically this segmented bar graph. So the side-by-side bar graph just kind of takes apart that segmented bar graph. Is there an association between gender and type of toy? Notice that it says association and not cause and effect. Well, I would argue that there is an association. You can tell there's an association because when you look at the two segmented bar graphs, they look completely different. Notice this dark blue at the bottom of the female chart is much bigger than the dark blue at the bottom of the male chart. The green female the female bar segmented bar graph has a green section where the male bar graph doesn't. And also while we're at it, the light orange, maybe it's tan, I don't know, but this light orange bar over here for males is much bigger than the light orange bar over here. So the two segmented bar graphs differ in very, very meaningful ways. A couple of things that we can say to describe this association is we could say that if we know that the male chart is the chart that we're looking at, for example, if we know that a student identified male, then we know that it's much more likely that they're playing video games than if they had identified female. Also, if they identified male, it's much more likely they played with or they identified dress-up clothes as their favorite toy rather than if they had identified as female. So there is an association between gender and toy type. We don't have enough information to know if that's if that is a cause and effect association, but we know that there is some kind of association. Okay. What would it look like if there was no association? Well, if there was no association, the two bar graphs would look exactly the same. Okay, so if we're taking a look here, I think it's easier to see this on the segmented bar graph. So let's take a look at the segmented bar graph here. Notice how they're the same graph. So if they are literally, or almost quite literally the same graph, then we would say that there is not evidence of an association between whichever two categorical variables we are looking at. You can see it in the stacked, what do we call that? The side-by-side bar graph, although I think it's a little less obvious than it is on the, by looking or making an analysis of the segmented bar graph. Okay, so no association, association. They are dramatically different, or they should be dramatically different from each other. And, you should kind of know the difference there. Okay, let's take a look at this next section. I know this is the first time we're doing these in class. So the next thing we're going to do is we're going to try to crystallize all the important ideas that we came across today during class. We only really looked at two different things today. The first thing was, categorical variables and what they were. And if you want a definition, of course, categorical variables report the frequency or counts and relative frequency in pie charts or bar graphs. Now, we also looked at two-way tables. Two-way tables, they look like a chart that separates data. We looked at three different kinds of relative frequencies. We looked at the marginal. A marginal relative frequency is a total from a row or a column divided by a grand total. The joint frequency is the total from the intersection of two different categories divided by the grand total. And a conditional total would be an intersection of two different categories divided by either the row total or the column total. Most students get this pretty quickly, so I'm not going to have any additional notes on this one, but I will take a look at the Check Your Understanding next. Now, typically in class, Check Your Understanding works a little bit like an exit ticket. So as you're working on this, I should be coming around to your table and taking a look at your work, maybe putting a stamp on your table that says that you did this. So let's take a look at this Check Your Understanding together. Firstly, students at a local high school were asked which gaming system they preferred, the PlayStation 3, the Xbox 360, or neither. The graph at the right shows results, and explain why this graph might be misleading. Go ahead, pause here if you want to think about it and write about it. Maybe you want to look down over here at the vertical axis and see what vertical axis we're given. And yeah, that seems to be a big problem. The vertical scale doesn't start at 0. So this makes this graph look like the PS3 is preferred by over 2 to 1. But in reality, it's only 3 percentage points, 46% to 49%. So it's not, it's not double, certainly not triple the amount of people prefer the PS3. So that's kind of misleading. Okay. Furthermore, we don't even see the neither bar, so that makes us think that it's 0. Also, because of the size of the width of that PS3 and the Xbox 360, that misleads us as to the true proportion. So really, you shouldn't be using pictographs in AP Stats. Just draw a bar and make sure that the vertical scales start at 0. Number 2. An article in the Journal of American Medical Association reports the results of a study designed to see if the herb St. John's wort is effective in treating moderately severe cases of depression. The study involves 338 patients who were being treated for major depression. The subjects were randomly assigned to receive one of 3 treatments, either St. John's wort, Zoloft, or a placebo for an 8-week period. The two-way table summarizes the data from the experiment. So here we have our two-way table. I notice that there are no marginal totals, so maybe we should write those in real quick. Okay, I think my addition works out here. Notice over here we've got a grand total of 338 patients or subjects here who took a traditional or a treatment, either St. John's wort, Zoloft, or placebo. So, letter A, what proportion of subjects in the study were randomly assigned to take on St. John's wort? Well, how many were? That's 113 out of 338. So 113 out of 338. That's equal to 33%, or 33.4%. Okay. Why does that value make sense? Well, I think if we're going to be doing an experiment, about a third of them should be assigned to each treatment. Next, find the distribution in the change of depression for subjects in this study using relative frequencies. So here what we're going to do is we're going to take all the different changes in depression and we're going to find what proportion of the total each represents. So what is our first category? Well, our first category of change depression is full response, and that's going to be 91 out of 338, 26%, 27%. Next one is partial response. And how much is that? That's 55 out of 338. And lastly, we'll look at no response. That is 192 out of 338, or about 57%. Okay, so that is our distribution for the change in depression. What percentage of subjects took Zoloft? Actually, let me go backwards here. I want us to remind us all that what we are looking at here, since we're looking at this margin over here, this is actually what we would call a marginal distribution. Marginal distribution, because our values and our numerator comes from the margin. Okay. Next, what percentage of subjects took Zoloft and showed a full response? Zoloft and full response, that is 27 out of the 338 total. So 27 divided by 338, that is about 7.9%, or let's say 7.99%. This is a joint frequency. Okay. Our number on the numerator, 27, comes from the intersection of two different categorical variables. So that's going to be a joint frequency. So that's it for today. Hopefully this is a pretty easy start into AP Statistics, and we'll see you tomorrow when we do more. Have a good day, everyone.